Hello everyone, today let's try some games. This is a famous game, Tower of Hanoi. So this game, actually you can see the description, the object of the game is to move all the disks over to Tower 3, which is on the right hand side by drag and drop. But you cannot place a larger disk onto a smaller disk. That is the only rule. And the goal is to move the entire pile of disks from the left hand side of a pillar to the right hand side of a pillar. So the tasks is clear and the rule is simple, but it is a game that troubles a lot of students. And also this game shows a very basic idea in computer programming, which is called recursion. So that means break a large problem into smaller problems, and then solve the easier ones. Let's start with a disk of 3, and then we go up to 7. Along the way, I will tell you how to do what to do, because once you increase one disk, it will become very complicated. At the bottom of the screen of the small window, you can see there's minimum move. So you can move at minimum 7 steps. How can we do this? We can try to put the smaller one either in the middle or to the left-hand side tower. Then which one should we put? That is a good question to ask yourself before we start this game. So the purpose actually is to put the bottom one, the bottom disk, which is the largest disk, to the right-hand side tower. That means the next to the largest will need to be put in a different tower as the largest disk. And the smallest disk, therefore, will be need to put to the same tower, move to the same tower as the largest disk. It goes one to another, each another disk to the same tower. So that means the smaller disk need to go to the right-hand side tower at first. Then the middle one goes to the middle tower. Then what should we do? We should put the smaller disk back into the middle tower, which means we can now move our largest disk to the right tower. So this takes our 4 moves. You can see that the number of moves is shown on the top of those 3 towers. The next step will be easy because now we need to take the largest disk in the middle tower and put it to the right hand side. Therefore, the smaller one should go to the left, and then we can put the second to the largest disk, and then we can move the smallest. So we have exactly 7 moves to finish this puzzle. Now let's increase the number of disks. We have 4 disks now. Think about it. We need to put the largest disk to the right tower, and the kind of a pink disk, therefore, should be put in the middle tower, and the dark green, the greener disk should be put to the right tower, and the top smallest disk, therefore, should be put in different, which is the middle tower. Therefore, we start from putting the smallest disk into the middle tower, and of course, this one, second smallest, need to be put to the right tower. Then we have to put this one, the smallest, on top of the second smallest. Then we can put the pink one into the middle tower. Now, since we need to put the second smallest, which means the greener disk, in the middle, that means the smallest, the less greener disk need to be put to the left. So we can put the greener disk in the middle. Then we can put in the middle. Now, everything, all the disks other than the largest, the yellow disk, are in the middle in the correct order. Then we can put the largest disk to the right tower, which finishes this pass, actually. This is kind of a sorting algorithm for computer science. So if you know the idea behind all this movement, it will help you to study computer science in GCSE and A-level, and also learning programming language. Now our task is to put the pink disk to the top of the yellow disk. Therefore, the greener disk must be put to the left, and the smaller disk, therefore, need to be put to the right tower. Okay. Always using this logic, then we will complete all the challenges, no matter how big, how large the disks, how many disks we have. So now we have the second to the largest disk on the right tower, and then our task, of course, is put the second smallest to the right. Therefore, the smallest need to be put in the middle. Then we put the second to the smallest disk on top of the pink, then final move, 15 moves, exactly the minimum moves. Okay, now at last, let's try disk 5 disks, because when we increase to 6, 7, 8, the moves will be increased tremendously. So I will just illustrate the ideas, and you need to apply the same, exactly same ideas, no matter how many disks you choose. Okay, so to the 5. Again, since we have the largest disk need to be moved to the right tower, therefore the pink also should be moved to the right tower, therefore the smallest. And then the second to the smallest in the middle, of course, then don't forget we have to put it back. And therefore we move this pink one to the right tower. Now we need to move the smallest to the left, the second smallest to the right, and then we have everything actually sorted. A small tower sorted to put entirely to the right tower. Again, now we need to move the second to the largest to the middle tower, and then think about it. We need to move the pink tower on top of the second largest disk. Okay, therefore, the smallest need to be put in the middle, the less smallest, the second smallest should be put to the right, left, and then we do this, so we can put the pink one on top of this yellow one. And using the same logic, we need to do this move. So we have entire tower of disks other than the largest disk in the middle already. So now we can put the largest disk to the right tower. Now apply the same logic. The yellow one must be put on the right tower, and the second to the smallest green disk need to be put on the right tower as well. That means the smallest one goes here, then second to the smallest goes to the right, then the smallest go to the right now. Then we can put this pink one to this left. Then we can put the smallest one to the middle, and second to smallest to the left, and then smallest to the left. Now we can move this yellow, second to the largest yellow disk, to the right tower. Again, we need to put the pink one to the right, therefore, we need to put the smallest to the right, and this second to the smallest to the middle, then the smallest to the middle. Then we can put the pink one to the right, and then we can put the smallest to the left, second smallest to the right, and then we finish in 31 exactly minimum moves number. Okay, so I hope you can use this idea, understand the logic behind, and try disk number 6, 7, and 8 and be successful. So if you check 6, 7, and 8, and for 8 disks, you need 255 moves. It will be very easy to get lost in the middle, but if you always think about the next largest will always need to be put to the right tower, and the others will be put into an alternative tower, then you will solve this problem. And if you understand programming language, you can apply this algorithm into programming language, ask computer solve it. Have fun. See you next time. Bye bye.